Alright guys, today we're going to take what we know about domain and range and we're going to add a couple more vocabulary words that we see with our different types of functions and how to identify functions continuing with that information. So this particular problem talks about a roller coaster. They can be scary rides. Here we have a graph of the heights that a roller coaster can reach, where the first is 1,250 feet of track. That's how long this piece of track is, and then you can see the height that each piece gets. So it does say that it is a function because each input, remember input is x, value has one and only one output or y value. And we can see this does pass the vertical line test so that it is a function. Now, we're going to label this graph, and then we're going to put this in our journal tomorrow when you come into class. We have some different pieces. We can see that the domain does go from 0 to the 1250, but the range, again, like when we did our motion detector, is going to go 10 all the way to about 110. So remember that it does not matter what the scale is. You have to look at the actual graph. Here it talks about, again, the domain is your independent variable or your x, the distance along the track. And when we write this, it is continuous, so we're going to use inequalities. We also have a range. Range is your dependent or your y value. And when we do that, you see your range down here. Let me move this over some. And you can see your range again from 10 to 110. Now, we have lots of vocabulary, and we're going to come back to this graph and we're going to label it so we can label it in class on the next page. So if you'll look here, it says the graph shows that the data is continuous. We talked about discrete the other day. It has dots. Because this data is continuous, that means we're going to have to use inequalities. All right, if it's dots, that's when we list it. Domain and range including all numbers with no break, so we can draw it with our pencil. Where discrete, again, that is our dots, has individual points. So when we talked about the pull-ups and the push-ups. Other important pieces, we have the Y-intercept. That's where it crosses the y-axis. When we write an equation, that's our b value. We're going to talk about our relative maximum and our relative minimum. So this is the highest or lowest. Notice f of x. We talked about that the other day. The lowest or highest y value within a particular interval. So what I would like you to do real quick is we're going to go back to this graph and we're going to label those things that we just talked about because I want you to have a visual of what that looks like. Right here, this is a relative minimum. It is a low point. Now, but Mrs. Ray, we also have a low point at the Y-intercept, which is our B, and we also have a low point here. Now, those are the absolute lowest minimum numbers. So, while yes, they are a minimum, they are called the absolute minimum. Okay, whereas the 0 to 10 is also a b value. So an absolute minimum, meaning it is the lowest that the graph goes. This, what is that? That's about 550, 30. That's a relative min. That is a low point in the graph where it changes direction, but it is not the absolute lowest point. So here we have, this is a relative maximum. It is a high point in the graph. That's where the graph changes direction. However, this coordinate is the absolute maximum. It is the very highest point in the entire graph. So if we turn the page, we can answer some questions about these, where it talks about what is the y-intercept of the function. Well, we just talked about that. Where was it? It was at 0, 10. Make sure you write your y-intercept as a coordinate. And what does it represent? This is the starting point for the roller coaster. We can say the coaster is 10 feet high, or 10 feet off the ground. The relative max, technically we have an absolute and a relative, so if it's absolute it's also relative, so we can say 110 feet and 90 feet. We can have two of those. Remember that the max and the min, those are only Y values. Do we have an absolute max? Yes, it is just the 110. And that is the highest point of the coaster. What about a relative minimum? Well, the relative minimum was 30 feet. And then we have an absolute minimum at 10 feet. And that is the lowest point of the coaster. On the next page, we have another little graph for us to look at. Suppose you got on a roller coaster called Cougar Mountain and immediately started climbing track in a linear fashion as shown on the graph. Can we state our domain and range for this? I would like to see you draw your function window for this graph and identify the domain and the range. It talks about number 7, what is the y-intercept? What are the absolute max and mins of the function? In this case, it's going to be your endpoints. Remember, those are only y values. And does the function have a relative max or min? I'm going to ask you to do those practice based on the vocabulary we just talked about. We're going to go over that in class tomorrow. Have a good night.